Okay, guys, today we're going to do a quick section 613, which is called the add multiply property for exponential functions. And then we're going to do 614, which is the final section in the chapter, and it's about the word problems or the exponential models. And they'll be pretty similar to the models we've done in the past. So let's talk about this 613 first. There's a property called the add multiply, and that's for linear functions. Okay, in a linear function, if your x value has a constant adding, in this case we're going +2 every time, then you are going to add the same thing as you move down the y list. In this case we're adding -3, or you could think of it as -3, -3. Okay, that's linear. That's what makes a nice smooth even growth of a linear function, or even decline of a linear function. Exponential functions have what's called the add multiply property. In an exponential function, if you do the same steady growth of the x, 1, 3, 5, 7, it doesn't have to be a +1. It's when you add the same thing. You're going to, on the y side, multiply, not add, the same thing. So here, I multiplied by 1/2. Same thing here, times 1/2, times 1/2. Not very complicated. It's just the way exponentials work. We steadily multiply instead of steadily adding. And this would be exponential decay because it's dividing by 2, which is multiplying by 1/2. But the same steady +2 +2 on the x makes a steady multiplication on the y. So you're going to have two styles of questions. Style 1 is when I'm going to give you 2 points. I'm going to give you, for example, 8 and 25.7. Change colors here. And the other point I'm going to give you is 11, 16.8. And I chose one that didn't have nice, neat numbers just to make a point that, you're going to have to maybe use your calculator to figure out what you're multiplying by, but that's no problem. And the question will say find values above and below these in the chart. So the values that I can find values all day, but this I'm going with a +3 pattern. So I'm going to find the 14 and the 5, which will come from adding 3 and subtracting 3. So what I need to know is, what is this number that I'm multiplying by every time? Well, it's not an obvious number that jumps right out at you, but if you want to know what you need to multiply 25.7 by to get 16.8, then the answer is divide 16.8 by 25.7. Let's see what that is. 16.8 divided by 25.7. So my multiplication factor is this number. It's not pretty, but I'm going to store that. There's something you should know. STO down on the left of your calculator, store. And then I'm going to pick a letter. I'm just going to store that in letter A. So if I want to use that number, I can just use A. So from here on out, that A is 0.653, on and on and on. So back to my screen. If I want to know what I get when I get down to 14, I need to take 16.8 and multiply it by my number that I just found. And I can just use A. Whoops, wrong button. Alpha A. My next value would be 10.98. Okay, so back on this screen, 10.98 is the value that I get when I go one more step. It could be 11.0 if you were doing it to the nearest tenth. Okay, so then how do I get the number that y would be when x was 5? Well, if you multiply down this column, then you divide to go up the other way. Just reverse the process. So I need to do 25.7 divided by A to get 39.3. So that's one style. I'll give you numbers in the middle, and it might ask you to find 1 or 2 above it and 1 or 2 below it. But it's nothing fancy. It's called the add multiply property. The other one would look something like this. 2.7, 3.1, 3.5, 3.9. And then over on the y side, I've got 1200, 840, 504, and 252. And the question is this an exponential relationship or not? All right, and to check this out, we're just confirming to see, does the add property work? Or excuse me, the add multiply property. So I've got a constant adding over here. I'm going plus 0.4, plus 0.4, plus 0.4. If that's the case, then whatever I divide by or multiply by to get from one term to the next needs to be consistent the whole way through. So basically 840 over 1200 would have to equal 504 over 840, which would have to equal 252 over 504. So let's check it out. 840 divided by 1200, which is the number I need to multiply 1200 by to get 840, is 0.7. 504 divided by 840, 0.6. So right away you can tell, I didn't even have to check the last one, this is not a constant multiply. If this were exponential, the add multiply property would work. That's the other type of question they could ask you. All right, so let's move on to exponential functions as models, or otherwise known as exponential word problems. All right, these word problems are going to have the form a times b to the x, where a is your starting value and b is what you multiply by every time x goes up by 1. The problems you've seen in the past, if this is a quadratic problem, they give us 3 data points. If it's linear, they give us 2 data points. The data they give us lets us come up with the equation, and then we use that equation to answer questions. So A is find the particular equation. The 2 data points that they're giving us are, after 0 amount of time, I have $1,000. And after 1 year, I have $1,052. So I earned $52 of interest just for letting the bank have my money. There's a beautiful aspect of life that you'll care about later on called compound interest. You need to start investing your money early, as soon as you get your first job, and then you can retire a millionaire. But besides that, the data points are here, and they're always going to give us the kind of starting, the 0 data point. All right, if they just give us 2 data points without the initial value, then it's going to be impossible to find the correct exponential value, because there are multiple ones that could go through that, through those 2 points, or at least we're not going to be able to find the proper one. So here's a couple ways to approach this. Number one, I'm looking for A and B, right? You can automatically know that A is the number that goes with 0, and here's why. Y equals A times B to the x. I know the data point 1,000 equals A times B to the 0. If they give me the 0 point, see what happens? B to the 0 is 1, so that just cancels out, and I get A equals 1,000. So I know right now that Y equals 1,000 times B to the x. Well, the reason they give me a second data point is so that I can figure out what B is. So 1,052, I'm going to plug that one in, times B to the 1. So I divide by 1,000, and B equals 1,000, or 1,052 divided by 1,000, which is 1.052. All right, this is a bank account that pays 5.2% interest a year. But anyway, our final equation is y equals 1,000 times 1.052 to the x power. Okay, so here, that's one way to go about solving question A, what's the particular equation. Another way is like this. In your calculator, go to Stat and Edit, and clear out any data that you have from previous questions. The 2 data points I know are 0 and 1. And 1,000, the y's are 1,000 and 1,052. And this is something we've done, Stat over to Calc. This is not quadratic or linear regression. This is exponential regression. It will default to list 1 and list 2 unless you tell it otherwise. So exponential regression gives me A is 1,000, B equals 1,052. And that R squared equals 1 and R equals 1, that just tells us that it's a perfect fit. It's not not an approximation of the best fit graph. It is the perfect graph. So 1,000 times 1.052. And you can see it tells you even y equals a times b to the x. So it tells you what the equation should be. So that's another option. In this case, it wasn't that hard to solve for b, but the calculator is always a good possibility as well. All right, so part B, how much are we going to have in 10 years? The thing about compound interest is you earn some interest the first year. We earned $52 the first year. That interest starts to earn interest, and then that interest starts to earn interest. So that's the compound part. And hopefully, in the long run, your money does this, and then this is you, retired, rich, and happy on your yacht. So 1,000 times 1.052 to the 10th. Will give us, missed times. Okay, got it. $1,660.19. 1660.19. All right, so you might be thinking, you know, over the course of 10 years, I made $600. That might not seem a lot, but you made $660.19 for doing nothing, just for having your money in the bank, and then you would be depositing it all, you know, every month you deposit, and that's how it grows big in the long run. Part C, how long is it going to take to double our money? So let's look at the original equation. Y equals 1,000, 1.052 to the x. If we double our money, basically they're giving us a y value. I'm telling you my current balance, my amount of money is $2,000, starting at $1,000 and earning 5.2% every year. And now I need to solve for x. All right, so my first step is going to be to divide by 1,000 each side, and I get 2 equals 1.052 to the x. Now, this is where our new strategies come into play. When your unknown is in the exponent, how are you going to get out of there? You're going to log both sides. Why do we choose to log both sides? Because logging a power makes that exponent drop out into the front, and now we're able to work with it. Divide both sides of the equation by log of 1.052, and that'll be it. So we need log of 2 over log of 1.052. Log of 2 divided by log 1.052 should do it for us, and we get 13.67 years. All right, so all right, you want to turn your 1,000 into 2,000. In this case, give it to the bank and let them keep it for 13 2/3 years, and they give you back 2,000. There are obviously a lot of variables in the real world that would make that differ, like the stock market and interest rates and all that crazy stuff that I don't really understand. But what I do know is you want your money compounding your whole life so you can get over here to happy, rich yacht life. All right, so that was the end of chapter 6 for us. We have the add multiply property, and we have word problems, and you can get those equations the old-fashioned way or in the calculator, and then use them to plug in x's and y's. All right, so I'm wishing you a happy yacht retirement. Hopefully I'll be on mine soon, 20 years from now. Young out.